Right, Trig lecture 2324, OSA 2817. Student will evaluate described geometric series. Now, just like when we did arithmetic series, series is when you take the terms of a sequence and you add them together. So that's what we're going to be doing, but this time the series is going to be geometric. Okay, so the student will evaluate or describe geometric series, and geometric series that is written in sigma notation. We talked about sigma notation with arithmetic series. This time we're going to use sigma notation in geometric series. So here we go. The sum of a finite, that means there's going to be a first term and a last term. It's not going to be an infinite number of numbers. The sum of a finite geometric series can be found using this formula. This is the sum of n terms is equal to the first term times the quantity 1 minus the common ratio, which we've talked about, raised to the number of terms, n. Close that, over 1 minus r. Now, if you're just going to be putting these right into the calculator and not doing this little bit of math in your head, you might want to put this in parentheses too, or you'll find yourself getting the wrong answer, okay? I usually do this little arithmetic in my head and divide by whatever that turns out to be. But if you're not going to, if you're just going to plug it into the calculator the way you see it, make sure you put this in parentheses. Okie dokie. Let's take a look, see what we got here. We got find the sum of the related or described geometric series. Well, here I have a geometric series. It tells me this is what it looks like, and it tells me I'm going to have 8 terms. I'm going to move that just a little bit so I can see if it is geometric. Negative 12 divided by negative 4 is positive 3. Negative 36 divided by negative 12 is positive 3. So I know what my common ratio is. The common ratio is 3. I've got the number of terms is 8. Well, what exactly do I need here? I need the first term, the common ratio, and the number of terms. That's all I need. Well, I know the common ratio, I know the number of terms, and I'm looking at the first term. So here are the 3 pieces of information I need to plug into this formula. So let's move this down here real quick. The sum of n terms is equal to, let's move that down a little bit, a sub 1 times the quantity 1 minus r to the n all over 1 minus r. And if you're going to be plugging it into the calculator just the way you see it, you might want to put those in parentheses. All right? So let's plug these values in. As I said, all we need is the first term, the common ratio, and the number of terms that we're looking for, which we have all 3 of those pieces of information. So here we go. We're going to find the sum of 8 terms, because that's what it asked us to do, is equal to the first term, which we can look at the series itself and see that it's negative 4. This is a sequence, actually. We're finding the related series. Related means negative 4 plus negative 12 plus negative 36, so forth and so on. That's the related series. So I will try not to make the mistake of calling a series a sequence and vice versa. First term times 1 minus r, what do we find that to be? 3. To the n, that's the 8th term we're looking for. All of this over 1 minus 3. Now normally when I put this in the calculator, when I do negative 4 times parentheses, close parentheses, then I hit divided by, I'll do this in my head and call it negative 2. I've seen some kids that have been saying divided by 1 minus 3. Well, your calculator will divide this by 1, following the order of operations, perform that quotient, and then from that quotient, subtract 3. So if you're going to just plug it in just the way you see it, make sure you put this in parentheses, okay? And that way, you won't, your calculator will perform the operation you actually want it to. If you don't do that, it will mindlessly follow the order of operations and you can get the wrong answer. Not that the calculator made a mistake, it's just following the order of operations. So let's see what we get. The 8th term is, and hopefully we haven't made a mistake. Let's see if I can find my calculator. Negative 4 times the quantity 1 minus 3 raised to the 8th power divided by equals, I get negative 13,120. And that is, I think, everything we were asked for. Find the sum of the related or described geometric series. We did, and now I just want to see if that sum is correct. We keep multiplying this by 3 until we have 8 terms. And then add all those up, we should get negative 13,120. And that's what the key says, so yay! All right, let me move these to the left a little bit. Let's take a look at another one. In this case, it gives us, it's described to us as the first term is negative 2, the nth term is negative 512, and r is 2. It's describing it to us. And what is it that we need? We need the first term, we need the number of terms, and we need r. We don't have the number of terms here. We have the first term, we have r, but we don't have the number of terms. We have the nth term, but we don't know what n is. So we're going to have to use the explicit form to find the nth term. And the explicit form was a sub n is equal to a sub 1 times r to the n minus 1. That's what we did for the last couple of days, using the explicit form of a geometric sequence. So I'm going to use this, and I'm going to find n. Watch how this works. Hopefully I won't mess it up. I'm looking for a sub n. I'm looking for n. They gave us a sub n. They didn't give us n, so that's what we're looking for. I'm going to call that negative 512 is equal to a sub 1 is negative 2 times r, which is 2, to the n minus 1. Well, I don't know what n is. That's what I'm looking for. Here's how we're going to find it. I'm going to solve this for n using a little trick that I'm going to show you. You might remember it from Algebra 2. We're going to isolate this part right here first, get rid of this multiplied negative 2 by dividing by negative 2. And that will give me positive 256 if I haven't made an arithmetic mistake. This will give me 2 to the n minus 1. And let me check my arithmetic because it's early and I'm old and I make mistakes. 512 divided by 2. 256, yay! And now, here's what I'm thinking. If this is 2 raised to some power, I'll bet you this is 2 raised to some power, and I'm going to figure out what that power is. I'm just going to start multiplying by 2's with my hands. Or you could just take your calculator and say, well, let's see if it's 2 to the 6th. 2 to the 6th equals, well, that's 64. It's got to be 2 to the something bigger than 6. Let's try 2 to the 8th. 2 to the 8th equals, hey, 2 to the 8th is 256. You can do it with your calculator just by trial and error. It wouldn't take you too long. Or you can do what I was going to do and just count it off on your fingers. I was going to go like this. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 64, times 2 is 128, times 2 is 256. Whoop, I made a mistake. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. Yeah, I don't know how I came up with 7. I'm old, my brain doesn't work. At any rate, if 2 to the 8th is equal to 2 to the n minus 1, then it stands to reason that 8 and n minus 1 have to have the same value because they're equal. If the bases are equal and we're raising them to the same power, they'll be equal. So these powers must be equal. So I just say 8 is equal to n minus 1. Now we have a pre-algebra problem. Add 1 to both sides, and now we know n. N is 9. And once we have that, we can use our formula because we'll have n, we'll have the first term, we'll have r, and we have n. Those are the 3 things we need. So I'm going to scooch this over and perform that operation. The sum of n terms is equal to a sub 1 times the quantity 1 minus r to the n all over 1 minus r. And we just found what n is. So we're looking for the, this is the 8th term in every case, unrelated. Oh no, we're looking for the 9th term in this case. That's what we just found. I'm brain damaged. Looking for the 9th term. The first term was given to us as -2. 1 minus r was given to us as +2. N we had to look for, and we found it to be 9. And this is going to be divided by 1 minus r. And r was given to us as 2. Again, if you're going to plug this in just the way it looks, make sure you put the bottom in parentheses 2. Okay. We'll scooch this down just a little bit to make it a little easier on the eyes. There we go. Now we plug that into the calculator and hope we haven't made any mistakes. -2 times 1 minus 2 raised to the 9th power divided by -1022 is what I get. -1022. And now I'm going to check to see if that's correct. And if it isn't, I'm going to cry and say whang. But it's correct, yay. Okay, so if they don't give us the 3 pieces of information we need, and those 3 pieces of information are the first term, the common ratio, and the number of terms. Here they give us the first term, the common ratio, but they didn't give us the number of terms. They gave us the nth term. So we use the explicit form, found the nth term, plugged in everything we knew, and found out that our variable was in the exponent. And there are 2 ways we can deal with that. And I said, well, I bet they have the same base. And they did. And it said, well, if the bases are the same, then the exponents have to be the same. And we had a pre-algebra problem, and we found n. Then we had the first term, r, and the number of terms, and we could use our summation formula. Okay? There won't be a whole lot of these. There may not even be one of those on the test, but it's good to know. There may be one on the test, though. You never know. Okay, let's see what we got here. We have the first term, r, and the number of terms. So we can take our summation and just plug everything right in. This is a described geometric series. It's describing it to us. It says, well, here's the first term. Common ratio is 5. If I multiply this by 5 and then multiply that by 5 and multiply that by 5, and I do that 7 times, what would the sum of those numbers be? This is just described to us. So we've got S sub n is equal to a sub 1 times the quantity 1 minus r to the n over 1 minus r. And I'm going to make sure I copied that correctly out of my brain because my brain is old. A sub 1, 1 minus r to the n, 1 minus r. Yay! So now we just plug stuff in. Excuse me. We are looking for the 7th term. These are the 3 pieces of information specifically with it that we need, and they just gave it to us. So yeah. A sub 1 is -3. 1 minus 5 to the 7th over 1 minus 5. And again, if you're going to evaluate this expression, just the way it looks, instead of calling this -4 in your head, if you're going to say divided by 1 minus 5, make sure you put that in parentheses. Okay, so we'll get, whoops. We'll wind up with the 7th term, or the sum of 7 terms rather, being whatever we get here. Let's see if we can get it. -3 times the quantity 1 minus 5 to the 7th, close, equals, divided by, equals, I got -58,593. Is that right? I would like to think so. Let's take a look and see. Yay! So far so good. Let's take a look at one last problem here. Okay, they're given to us the sigma notation again. And so we're asking ourselves, what are the things we need? Well, I need the first term, so I'm going to plug in a 1 and figure out what this is. Well, I don't even have to do that. Remember, this is a sub 1. This is r in the general form of a sub 1, r to the n minus 1. So I'm looking at the first term, I'm looking at r, and the number of terms is right here. So I'm given just like this. It looks different, but I can do all of this arithmetic that it's going to ask me to do. Add up all of these 8 terms, plug in a 1 here, multiply by 5, negative 3 equals, then plug in a 2, plug in a 3, and I'll have 8 terms. This summation formula will add all 8 terms up without having to do all of that. Excuse me. So I'm going to have s to the n is equal to a sub 1 times the quantity 1 minus r to the n. All of that over 1 minus r. And I just plug in the 3 values that they've given to me into this formula, and then try not to mess up my arithmetic when I'm performing the calculation. I'm looking for the sum of 8 terms is equal to the first term, that's a sub 1 right there, negative 3, times the quantity 1 minus r is 5, to the n, that's 8, all over 1 minus r, and they tell us that r is 5. And again, we have to remember, if you're going to plug this into your calculator and not do this little bit of arithmetic in your head, make sure you put this in parentheses. And that will give us the sum of 8 terms is whatever that happens to be. Hopefully I'll get it right. Negative 3 times the quantity 1 minus 5 to the 8th equals, and I'm dividing that by negative 4, or 1 minus 5. I got negative 292,000. It's a weird looking equal sign. Negative 292,000, 968. Don't know if that's correct, but I've got the key right here, so let's take a look. Negative 292,968, yay. So what this is a summation notation. We know that the general form, this is the first term, this is the common ratio, that's the number of terms, n. Those are the 3 pieces of information we need for our summation formula. The summation just means we're adding it up. And so we plug those in the appropriate places. Try not to mess up our arithmetic when we add it into put it into our calculator, and hopefully get the right sum. This is going to be 8 terms that are added together. That's what this means. Okay. You can do this.